It's time to apply some core math knowledge to add an engaging feature to a Construct 2 video game. In this project, which I call Stairway to Heaven, we will be using what we know about straight lines to dynamically create stairs when a player pulls a lever. Instead of hard coding, we will use the power of code and our knowledge of slope, the equation of a line, and more to implement this feature using Construct 2's event system. Let's do some review. Slope measures the steepness of a line. You may recall that slope is rise over run. In other words, the ratio of a line's vertical change to its horizontal change. If you know 2 points on a straight line, then you can calculate its slope. In math parlance, slope is represented using the letter M. Let's take a look at an example. In this case, I have 2 points. I have one where x is 5 and y is 1, and I have one where x is 18 and y is 3. The point 5, 1 is referred to as x1, y1 because it's considered the first point. And the point 18, 3 is referred to as x2 and y2 because it's considered to be the second point. To calculate the slope of the line that runs through these 2 points, I use the formula shown here. In the numerator, I find the difference between the y coordinates. This gives me the rise. In the denominator, I find the difference between the x coordinates. This gives me the run. And here you have it. Our slope would be 2/13 because for every vertical change of 2, there is a corresponding horizontal change of 13. If you know a line's slope and one point that runs through it, you can calculate the equation for that line. This is commonly referred to as y equals mx plus b, where b represents the y-intercept. Remember, the y-intercept is where x equals 0. In other words, the y-intercept is where the line crosses the vertical y-axis. If you know the equation of a straight line, then you can find any point on the line using basic algebra. Let's take another look at the example that we've been working with. Let's say I know the slope of my line is 2/13 and that I know one point the line passes through is where x is 5 and y is 1. To find the equation of that line, I can use these 2 pieces of information and my mad algebra skills as shown here. I start by plugging in my slope in place of m. Then I substitute x and y in the equation with the coordinates from the one point I do know. From there, I use simple algebra to isolate y, and voila, the equation of my line in classic y equals mx plus b format. Throughout your math career, you have used the Cartesian coordinate system in which you plot points and lines relative to 2 perpendicular axes which intersect at what's called the origin point, 0, 0. Under this scheme, the y, or vertical axis values, increase as you go up, and the x, or horizontal axis values, increase as you go to the right. Your knowledge and experience of the Cartesian plane will serve you well in game design, but you will have to think flexibly because things need to be translated a bit. When it comes to 2D games, the way we describe position is somewhat different. We still have 2 perpendicular axes named x and y, but the origin, where x is 0 and y is 0, is considered to be the upper left-hand corner of the screen. Under this pixel-centric scheme, the x values still increase as you travel right, but y values increase as you go down the screen. It is as if the y-axis that you are used to has been reflected across the x-axis. Take a close look at the graphic here. Notice how y values increase the farther down the screen you travel. Let's put this into context by revisiting our Stairway to Heaven demo. We start with 2 stairs that we can think of as points on our 2-dimensional plane. One stair is positioned where x is 960 and y is 864, and the other is positioned where x is 1824 and y is 288. Notice how y values increase as you go down the screen. Besides the differences in how our 2-dimensional plane is set up, all our other math knowledge holds true. For example, since I know 2 points on the line, I can determine both the slope and the equation of that line. If you look closely, you will see that our line has a negative slope. This is because y values decrease as you rise. This makes sense because the y value associated with the top of the screen is 0. Our y-intercept, where the blue line crosses the y-axis, is at 1,504 pixels, way down the screen. Again, large y values will be found down the screen because values increase in that direction. Let's apply what we have learned. I will be providing you with a partially completed Construct2 project in the form of a CapEx file that you will be completing in order to experience these concepts in action. You're going to start by downloading the starter CapEx file. Then, you will be creating variables that will store the results of the calculations needed to dynamically build our staircase. Throughout the process, we will be thoroughly testing our solution, peeking behind the scenes at the events and actions we are coding. Start by downloading the starter project and opening it up in Construct2. You can simply double-click on the CapEx file. You will find that there is a single layout named Stairway, which has all the objects already placed on it. You will find two event sheets, Player Event Sheet and Stairway Event Sheet. Leave the Player Event Sheet alone and focus on the Stairway Event Sheet, which I have strategically commented to assist you in this process. Notice there are two stairs. You can examine each properties in the Properties bar. Notice how each has a unique ID and position. We will be using this information to create our stairway. Next, we need to create some variables. Remember, a variable is just a fancy word for a place to store information in a program. We will be placing these variables in our Stairway Event Sheet. Go to the Stairway Event Sheet. You will notice that there's already one global variable named Stairs. Let's create a new global variable by right-clicking. Choose Add Global Variable. Name this one x1. This will be a number that will store the x-coordinate of our first stair. Organize it by dragging it above the stairs at the top of the event sheet. Let's follow the same process to create a variable named y1, which will store the y-coordinate of our first stair. Now it's your turn. Pause the video and using the information from the table, create the additional global variables that you need before moving on. Now it's time to perform some calculations that will help us build our stairway. At this point, we should have a bunch of global variables at the top of the event sheet, and we are ready to use Construct2's event system to capture the unique ID and position of each stair. Notice how there's one event group called Stairway to Heaven. Within it is a trigger that fires when the player collides with a lever. This collision causes the pull animation to play, moving the switch. When the animation is finished, we have an opportunity to capture information about our first stair, the one whose unique ID is 20. We are going to add an action to the event associated with the stair whose ID is 20. Click Add Action, then System, and Set Value under Global and Local Variables. We want to set the x1 global variable's value to the current x position of our first stair. We will follow the exact same process to set the value of y1. This will be the current y-coordinate of our first stair. Let's test our code. Run the layout in debug mode. When you do this, you can see all the behind-the-scenes information, including the values of any global variables. Have the alien collide with the lever. When he does, you should see the global variable get set to the first stair's x and y coordinates. Using what we have learned, let's capture the information for our final stair, the one whose unique ID is 27. If you want, pause the video and see if you can do it yourself. Just follow the same process to set the values of x2 and y2, verifying them in debug mode. Now that we have variables that store the values of our 2 points, we can calculate the slope using the tried and true formula we talked about earlier. Place an action to set the m variable within the every tick event. Click Add Action, System, and then Set Value under Global and Local Variables. We want to set the m global variable to rise over run. In other words, y2 minus y1 over x2 minus x1. When you debug the layout, you should see that the slope has been calculated as -2/3. Following similar steps, we can calculate the y-intercept represented by the b global variable. Using simple algebra, you can isolate b. To get its value, use the expression y1 minus m times x1. When you debug, you should see that the y-intercept occurs when the value of y is 1,504. Now we need to calculate the number of stairs to create. Add an action that sets the value of the stairs global variable. You calculate the number of stairs needed by figuring out the distance between the first and final stair. Then divide that by the width of a stair. The expression should be x2 minus x1 minus stair.width divided by stair.width. When you debug, it should show that you need to create 8 stairs to fill the gap. We will use this calculation, saved in the stairs variable, to create our stairs using a loop. Click Add Event and choose 4 under Loops. Our loop will start with 1 and complete with whatever the value of the stairs variable is. In this case, the contents of our loop will execute 8 times. Drag the event under the comment as shown. We're going to use 2 local variables, x and y, to calculate where to spawn each individual stair. Add an action to the newly created event which sets x to x1 plus loop index times stair width. Here, we use a special loop index variable which tracks how many times we have been through the loop thus far. The first time through the loop, it will be 1, the second time it will be 2, so forth, and so on. Next, add an action to determine the y value of each individual stair. The value of y is determined using the tried and true equation of a straight line, m times x plus b. Now, add an action to spawn each individual stair. Click Add Action, System, and then Create Object under General. We want to create a stair object on the game layer, positioning it using the values we calculated stored in the local variables x and y. When you debug the layout and have the player pull the lever, you should see stairs being created. You can even explore the stair object instances. Now there should be 10. Sometimes it's hard to wrap your head around what happens in a loop. So take a minute to look at this table to visualize how the coordinates of each stairs are being calculated. Follow along to add a little finishing touch so that the stairs appear one by one after a short wait. There you go. That looks much better. Always make sure to save and test all your work thoroughly. In this case, we have created a purely dynamic, programmatic solution, and so it should work no matter where we place our first and final bricks. Play around with it and see how you can extend and enhance this demo. How could you use this in one of your games?